Hi, my name is Matt Johnson-Pint, and I am from Sentry. I want to tell you about Sentry's new offering for .NET MAUI. We are adding a new SDK to the Sentry family of SDKs, and that is specifically for MAUI. We're very excited about this. Let me tell you a little bit about what Sentry does. We're an error monitoring solution, first and foremost. We also have performance monitoring in our portfolio. I'm going to talk a little bit about that later. But basically what Sentry is for is, say you develop your brand new MAUI app and you deploy it on all your platforms and something doesn't quite work on it. Well, you would really like to find out about it before your users do, before somebody calls and complains. It would be great if you had a very easy way to bring all of that forward into your application. And keep in mind, like, you're writing a mobile app. What if it's offline? How do you even find out about those things? Well, Sentry can handle that by simply storing everything and caching it locally, and then sending it into your Sentry dashboard when the error has when the devices come back online. So let me show you a little bit about how to get started with MAUI. If you have your MAUI application, you do create MAUI app is something you're probably already used to. All you really have to do is say, use Sentry and give it any of the options that RSDK offers, but the only one that's required is what we call the DSN, or the data source name. When you sign up for a Sentry account, you'll be given this string. It's not a secret, but it's how we know how to give the data coming out of your application into your specific dashboard. And what do you get for that? Well, like, here's an example application crash. This happened in a test app that I was doing, and you could see that not only did we get all the details about the application, including what version it was on, what version of .NET it was running, what operating system it was running on. We also have when did the crash happen, what was the stack trace from that crash. And for MAUI, we've got this thing down here called breadcrumbs, which I'll zoom in on over here on the right, where you can see a whole list of what happened leading up to that crash. So if I had, for example, what I'm showing here is that we started our app, the page was appearing, the MAUI life cycles of window created, activated, they are happening, and then the user clicked a button, and that's when we got our crash. The corresponding stack trace for that one looks a little like this, and you can see that we also have that it happened in the on button click event. So all of this stuff will come through on the dashboard, and we correlate them and group them and do everything that you need to do in order to distinguish one type of failure from another. Now, we give you all kinds of information about the device that was running on, which is really important when you're working on a multi-platform product like MAUI. There's way more here than you could possibly even see unless you wanted to zoom in on the screen. But I wanted to throw it all up on here just to give you a sense of all the things we capture. We've got the amount of memory on the device, how much was free in terms of storage, if the screen was a certain size or orientation. We'll tell you if the person had rooted their device, or if they were running it in a simulator or on a real device. We'll give you their time zone and their culture and all kinds of other information that you might need that's relevant to debugging that error in your application. For our MAUI offering, we also offer native mobile crashes for Android, and we'll soon have native mobile crashes for iOS. And what this means is we've taken Sentry's very good SDKs that already exist for Android and for iOS, and we've embedded them into the MAUI SDK so that you get all the benefit of a native error monitoring environment, even from your managed world. So here's an example. I specifically threw a bad instruction crash from some native code running within my MAUI application. And I got all of the information. This was on a Mac, all the way up from UIKit into Mono and up into Xamarin, and then showing finally into the application that I was testing. So this will really help if you're trying to debug something that maybe isn't happening in your own code or is caused by something going on under the hood. Let's do a little demo. So here's a Maui application. It's actually just the file new Maui project starter template. And the only thing I've done to it is I've added the Sentry Maui NuGet package, and I've done use Sentry right here. And let's run this. And you'll notice that when this runs on my little Android device, so this is running on my Android device, and I've got the getting started with Maui. Let's click this button. I'm sure you guys have done this a bazillion times. I've got something special in this code. Oh, what happened when I clicked it the third time? The application crashed. Now, if this was a real application, the user might be like, what's going on? And they might try to run it again. So they run it again, and they click the button, and it's crashing. So they might then like call you and give you some information out of the app info here, and that's really all you get. But thankfully, we have this app connected to Sentry. So if I go to my Sentry dashboard, and I wait just a second here, there is the error that we just created. You can see it came in twice because I had it happen twice. So what happened here? I've got a divide by 0, and it's happening on my Android device. And I can see in my stack trace here that it happened in my on counter clicked event, and it happened when the button was released and then its measure was invalidated, which is all happening underneath the hood. Let's take a deeper look at these breadcrumbs, by the way. I've got all the way up from the app handlers that Maui has, the navigation of the user, the UI handlers, every little bit of thing that's happening. And I've got a timeline so that I can tell like how much time is passing between these things. Maybe your app isn't crashing, but it's hanging in certain parts. Again, here's all my memory info, thread pool info. That's really cool. Device information, etc. Let's go back to our code and find that bug. So it happened when I clicked the button. Oh yeah, I put this code in here. It's truly doing a divide by 0. Don't actually do that in your own code, but that was indeed causing a divide by 0 exception. So we can find the source of that. Let's do something a little more interesting now. I've put a few other things in this application that will make it easy to try some of our native crash handling. So let's do this. I've got some Android-specific code here that's going to call into a Kotlin library that I've embedded into the platforms folder. So up here in my Kotlin folder, I've got this little bit of Kotlin code called Buggy, and it's going to throw an exception in Kotlin, which is running on the JVM, which is underneath the hood in my Android language, right? Or my Android platform. So let's call this and see how that comes through. Because remember, this time we're not calling .NET code. The .NET code is invoking Java code on the device, and it's going to crash there. So again, we're going to click 3 times. It's going to crash. And that will come through. I'll show you in a second. While we're waiting, because it does take a few seconds sometimes, I also want to show you that we can do the same thing with native code all the way down to the C++ or the C layer. So here's a C crash that is going to basically try to increment a pointer to 0. So this is not going to be good. And we're going to go out here, and instead of this little bit of code, we'll run another one. This time, instead of my Kotlin, we're going to crash in C. And all I'm going to do is I'm going to p-invoke into that C library that I've also embedded into our application. Let's give it one of those too. And sure enough, this will crash. But these are the types of things, just for demonstration, that could happen in your app in the real world, especially when you think about all the different types of devices and platforms that your application is going to run on. We'll click 3 times, and boom, it's crashed. Just for good measure, we'll run it again. Now, on a native crash, if the application crashes and it's literally like a native layer crash and it's shut down instantly. What we'll do is we'll write that crash off to disk, and then we'll send it to Sentry the next time the application starts. That's part of the caching process for Sentry. Let's go back to our issues. We can see some of these have come through, right? So here's that Kotlin one. It came through as a Java laying exception. And we get to see, all the way down to, okay, there's our on counter clicked, buggy throw. We came through into the Java layer. We called into that method through JNI and got our exception in Kotlin. Again, we still have all of our breadcrumbs. We still got our device information, lots and lots of stuff. And that C layer should be here too. Oh, actually, it looks like I didn't even wire it up correctly. So the error we got was a DL not found. But even a true C exception would end up coming through into the application, and we would end up seeing it here. So that's something that's important to know. And we'll have that capability on as many MAUI platforms as we can support. Right now, it's on Android. We're adding it for iOS. But it really distinguishes something that Sentry can do that others can't. Let's say we didn't want to just let these things go unhandled, right? So one thing we can do is we can use the Sentry SDK. Let's put a try catch around here. And we could do something like Sentry SDK dot capture exception. And you can see here in Visual Studio, we have a lot of other options, but the easiest thing to do is capture it. Now that'll swallow that exception, so it's not going to error to our user, but we can still get it to Sentry like that. That'll come through the same way as everything else. And there's a whole bunch of other stuff that the Sentry SDK provides for .NET that is available to you in MAUI. So that's it for the demo. I want to talk to you a little bit about where we're at and where we're going. So we've currently released 2 previews. We're at preview 2 right now. We have streamlined our MAUI integration, so it's a simple use Sentry in your Sentry build, on your MAUI app builder. We've given you device context information and breadcrumbs specific for MAUI. We support managed exceptions on all platforms. That's iOS, Android, Mac Catalyst, and Windows. And we have native crash support for Android. What's coming next in our preview 3 is right around the corner. We'll have native crashes for iOS supported. And we'll also be doing native symbol uploads. So what this means is as you're building your application, we can take your symbols and send them up to Sentry on the back end so that when your app crashes, instead of just seeing address offsets like you saw in this demo, you'll actually see stack traces with class names and other information coming out of your symbols. We'll be adding a release health feature, which is something we have in some of our other platforms. This is a good way to know not just when things are crashing, but which releases are healthy. So if you tell us that your application is version 2.5, and we see that version 2.5 is getting good health signals, and then we start seeing some crashes that are only happening in version 2.6, we can distinguish that on the back end and tell you, hey, there's something that you probably introduced in your new version. And that is supported in many Sentry SDKs right now, and we'll have it in Sentry MAUI for preview 3. Shortly after that, we'll be going to GA, which is really just going to be adding a whole lot of tests, making sure it's solid, fixing it up, and really making sure it's perfect for you to put into your application and gets everything right that we are currently offering. Down the road, shortly after that, hopefully, we'll be doing automatic performance instrumentation for MAUI. So right now, you can use Sentry's performance features in your MAUI apps if you want to, but you'll be wiring up the actual things you're tracking performance on yourself. So if you have part of your application that's doing some background work, you might want to start and stop a transaction around there, which you can do manually with the Sentry SDK. But we want to do that for you using all of the events that MAUI gives us, as much as possible anyway. So right out of the box, you'll get perf data for MAUI. We also want to give you mobile vitals. So like we can tell you like how long did it take for your app to start from when the user clicked the button to the first screen. We want to give you any information about when your application isn't responding. And some of our SDKs, we can actually give you screenshots of what the user was seeing when an exception hand was happening. And we certainly will be able to give you that for native crashes, but we're going to see if we can do it for managed crashes as well. Here's a little sneak preview. This is how we do performance monitoring for mobile vitals in our Android SDK. So this will come through on the Sentry dashboard, showing you your cold start times. And if there were any discrepancies between versions, you'd be able to see very easily how long it took for your applications to run. The nice thing about this too is it'll tell you whether the start times are different on different device families. So maybe your application runs really fast on iOS and it works really great on Android 12, but it doesn't work really great on Android 10. We would be able to tell you that information here. That's all I have for today. Thanks for joining. If you want to learn more, you can go to Sentry for .NET MAUI. I believe there'll be a link you can click on right here. Feel free to reach out to us at Get Sentry on Twitter, or just find us on GitHub or our Discord channel. And thanks a lot.